PowerPoint presentation on fault finding. As with the first one, we're looking at safe working procedures. So the first one was about health and safety. Now we're going to look at safe working procedures. Now, the safe working procedures are the same as the safe working procedures that we've dealt with all the way through the course, all the way through the unit. So safe working procedures, electrical testing may be carried out for a number of reasons. For example, quality assurance tests on electrical components, diagnostic testing, fault finding on electrical plant, and routine safety checks. Now, in the regulations, and I've got a copy which I've attached, and I'll put a link onto the classroom. I did it this morning. Under Regulation 14, places a strict prohibition on working on or near exposed live conductors. So it's really, they don't want you working on any live conductors unless it is unreasonable in all circumstances for it to be dead, and it is reasonable in all circumstances for the work to take place on or near the live conductors, and suitable precautions, including provision for suitable protective equipment where necessary, have been taken to prevent injury. So most of the time, and this is what we actually have when we do the inspection and testing, we call them the live tests, and we have dead tests. Now, the dead tests all have to be done with the system unenergized, but obviously with some of the tests, we need the electricity to be flowing. We need that electricity, we need the voltage, and we need the current to flow to be able to do those tests. So this is where we're allowed to do that under Regulation 14. But we have to make sure that we have taken all the safety working procedures are in place. So injury can occur when live electrical parts are exposed and can be touched, or metalwork which is meant to be earthed becomes live at a dangerous voltage. So the safe working procedures should include the following: effective communication, barriers, notices, and safe isolation. So you need, as I've always said, every step of the way, we need to communicate with people. You need to let people know what's going on. You need to let know people what's happening. If you're working in an area where there are other people, you need to have barriers. So when we've done safe isolation in the past, one of the main things that we've looked at is put barriers, because if you're working on an area where people can walk around you, the last thing you want is somebody walking into you while you're testing, or walking into something that could be potentially live. And notices, informing people of what's happening, or if items are locked off, or what's going on. And obviously the safe isolation, which we now have covered numerous times, and we'll probably do a whole PowerPoint on that again. So safe isolation, I just want to make sure I haven't missed one. That one's a blank one. If in full safe isolation procedure is not carried out, risks may be introduced as follows. So we've covered all this for: to yourself, risk of electric shock or burns due to contact with the wiring system; to co-workers, risk of contact with electrical parts when basic protection has been removed; to customers and clients, risk of shock or burns or damage to equipment attempting to use the system; to the public, risk of shock and burns, again, due to the lack of awareness of the potential danger; and to the building systems, risk of damage or electrical equipment, and to the building fabric. And we've covered those in a lot of detail. Use of equipment GS38. I've attached GS38 to your classroom, and we've had a look at it before, but this is just a summary. So to summarize, test probes should have finger barriers or be shaped to guard against inadvertent hand contact with the live conductors under test. Now, I've shown you that before, that if you were holding something straight without a barrier, and you put a little bit of force on your hand, and if your hands were slippery or sweaty or whatever, they could quite easily slip, and you could quite accidentally touch some of the live conductors. They also have to be insulated to leave an exposed metal tip not exceeding 4mm. And you'll see that on a lot of these questions and things, they have a trick question saying, you know, over 4mm. And what they're saying is up to 4mm, but no bigger than 4mm, measured across any surface of the tip. And this is just to make sure that when you're testing, that there is no possibility that that test probe could touch more than one conductor. Because if it had more than the 4mm, there was a possibility that you could touch two things and actually create a short between two things. Where practical, it's strongly recommended that this is reduced to 2mm or less, or spring-loaded retractable screen probes are used. And a lot of the test equipment we have nowadays on the safe isolation kits have those spring-loaded ends. When using a multimeter, have a suitable high breaking capacity, sometimes known as a HRC fuse or fuses, with a suitable current rating not usually exceeding 500 milliamps. So what they were saying is, if you are using a multimeter, and we strongly do not recommend it, but if you were using a multimeter and you were putting it across, you'd want to make sure it was fused so you didn't have a problem. So I'm just going to come out of this. I have to edit that bit, end bit.